coupled first order linear differential equations. And I've got two differential equations here, a dx dt and a dy dt. X is the number of foxes and y is the number of meerkats at time t. And we've got some initial conditions of 3 foxes and 6 meerkats. And a solution to these two differential equations is down here in red. So first of all, we're going to plot the differential equations. Now, because I've got an xy grid, I'm going to plot it as dy dx equals dy dt over dx dt. So I've put that in as y dashed equals and then OK. Now, our initial condition was x is 3 and y is 6. So I'm going to click at that point. So that would be our solution there. If I just do a couple more, just so we can see, a couple more clicks, so we can see a family of solutions there. But this is the one that refers to our particular solution. Now I'm also going to plot the two solution curves. Now I've got an XY grid, but what I want is in terms of t, so I'm going to do it as an XT grid. I just sort of drag that down there. And then I'm going to put in x is equal to and y is equal to. So I'm going to give it a name of x, because this was my solution for x. So x was equal to 3e to the power 0.3t. And then we've got cos 0.3t plus sine 0.3t. I'm going to copy that because my y is very similar. And then we go OK. And we can see the initial condition that t is 0, x is 3. And I'm going to put y in. So if I just change the name to y, and because I've got a tx grid, I need to put it in as x is equal to. And I just need to change the coefficient for cos, which was 2 cos, and minus for sine, and then OK. So I've got my x is in red and my y is in yellow. If I zoom in a little bit, I can see a little bit better of what's happening there. Now, if I just label those, so this was my x, I'll go to the text box, and then OK. And then I'll do the same with y, which is my yellow curve, and OK. Now, because the because the power of the exponential function is positive, eventually x and y are going to tend to infinity. But because we've got a sine cos, there is going to also fluctuate. But looking at the two curves, so y are the meerkats, so the yellow represents the meerkats. So quite soon, so within 2 years, the meerkats are going to die out. So really, we're not interested in what happens much beyond that. So I'm going to compare now the two curves. So if I go to Window and then Windows, and I want to look at page 5 and page 6 together. So I'm going to tile those vertically. So we've got the two together. Now, initially, we've got this point here. So initially, when t is 0, we've got x is 3 and y is 6. That corresponds to where the two curves cut the x-axis here, or the vertical axis. Now, initially, both y and x are increasing. So if we go over to the differential equation curve, we can see that initially both x and y are going up. And then back to the solution curves, we've got quite soon the y, or the meerkat, reaches a maximum. So if I go right click and point, and we're going to solve f dash. So at this point here, y reaches a maximum and then starts decreasing. So if we go over to the differential equation, we can see that there's a kind of a maximum somewhere here, and then y starts decreasing. So x continues to increase and y decreases. And going back here, so then a little bit further on, we see that y reaches 0. So I'm going to solve y equals 0. So at this point here, and we can see that at that point, x is still increasing. So if we go over to here, we can see that eventually the y becomes 0, but x is still increasing at that point.